Okay, so we left off here on number 9. It's saying to use the quadratic formula to find the solutions. So it's telling us straight out, it's not factorable, and we wouldn't prefer to do completing the square on it. So we start by getting ABC. A is 6, B is 3, and C is 2. And then we plug into the formula. If you don't have this memorized yet, practice that before our test. But of course, you can just look it up during the test. And then we get it ready for plugging in. So first we plug in our b, -3. b squared is 3 squared, minus 4 times a times c all over 2a. The front becomes -3, the bottom becomes 12, and here becomes 9, 24 times minus 48. So we get -39. Remember that when we have a negative discriminant, that means that we have no real roots. But our last step in simplifying this would be to take out the imaginary letter I, and you just have to leave the root 39 as is. You also could rewrite this as -1/4 plus or minus I root 39 over 12. Again, just breaking apart the 3 over 12 and reducing it. So this is probably the answer that I would be expecting. On apex, it may even stop here, and this is also an acceptable answer. All right, let's see how we're doing on this next guy. Oh, so easy. All it wants to know is the coordinates of the vertex. Remember that the formula goes like this, plus or minus a, oops, just kidding. Remember that the formula goes like this, plus or minus a, x minus h plus k. Remember that there's a minus in the formula, so your h, or your x value, your hk is your vertex. It's not just 722. This h is negative. If it's x plus 7 in the formula, it's a negative vertex. So my vertex is -722. Remember that the x value or the h value is opposite of the formula. Okay, let's go over here to this guy. Okay, this one wants you to rewrite from standard form into vertex form. We're going to do this by method of completing the square. So, step 1, move the constant. What we just did was made space for completing the square. Go off to the side and do the b work. I'm getting 16. We're going to be adding 16 to both sides. So 16 minus 15 yields 1. And this perfect square trinomial could be summarized as the x minus 4 factors. Now we just move the 1 back over. We get x minus 4 squared minus 1. So a x minus h squared plus k, our vertex form, is an invisible 1, x minus 4 squared minus 1. So my actual vertex is +4, -1, because the x value is opposite. It also asks if this is a maximum or a minimum. If you graphed this graph in Desmos, you would see that it is an upwards facing graph, or smiley face, smile parabola, which means that this vertex of 4, -1 is a minimum. In fact, all of the vertices that we have done in this chapter have been minimums because they've all been positive x squareds. Coming up in Unit 6, the beginning of January, we're going to be doing finally some with negatives in the front. They're going to be upside downs with maximums. All right, how many x intercepts? How can we answer this question? We could just use the discriminant. Remember that if we get a positive discriminant, it means we have 2 real roots. If we get 0 as the discriminant, we have 1 real root. And if we get a negative discriminant, we have no real roots or imaginary roots. 2 real roots means 2 x-intercepts. 1 real root means 1 x-intercept. And no real roots means no x-intercepts. Okay, let's go do the discriminant on this one and see what we get. The discriminant is part of the quadratic. It's just this little section that's under the square root. And what's under the square root matters in how our roots are going to come out. We need A, B, and C. A is 2. B is -8. C is 15. So B squared would be -8 squared. 4 times A times C. So that's 64 minus 120. And that's going to give me a negative. What is 120 minus 64? Let me grab my calculator. -56. Now, it doesn't really matter what kind of negative it is. It just matters that the discriminant is negative, which means no real roots. So if we imagine a graph that has no roots, it never touches. How many x-intercepts are there? There are no x-intercepts. You would say 0 on apex. So no real roots means no x-intercepts because the discriminant is negative. Now it asks us straight up, what are the x-intercepts? So now we want to try evil plan number 1, factoring. First, I'm going to take out a greatest common factor of 2. Then it's just able to easily be factored. 2 times 5 make 10. X minus 2 times x plus 5 are my factors. So my solutions are the opposite signs. So if my root is a 2, my x-intercept is 2, 0. If my root is a -5, my x-intercept is -5, 0. Notice the format that I write x-intercepts in coordinate form. What is the vertex? We're going to use the little vertex formula. So I need A and B only for this. So I'm going to go -b over 2 times A, which just yields 1. That's half of my answer for the vertex. That's my x value. So now I just need the y value, so I can plug back into the original equation to get the y. So here's my original equation, opening up this space for the x we just got. So 1 squared is 1, times -3 would be -3, plus 6 plus 15. And so 21 minus 3, that would just be 18. So x is 1, y is 18. There's my vertex. So step 1, we used vertex formula to get x. This is part of the quadratic. And step 2, we plugged in x to get y. Okay, let's go look at our last ones. Okay, these are solving systems of nonlinear equations by substitution. So solving by substitution. We've been solving to get x-intercepts this whole time. Now we're going to be solving by substitution to get points of intersection. So these are not necessarily the x-intercepts. These are just where the graphs are touching. So here I go taking, if y equals this, I can plug that equation in for y, or set these two equal to each other is another way to say it. Now to solve quadratics, I need to move everything over to make it equal to 0. Now I'm able to factor this in order to solve. Okay, I'm getting that x equals 3 is my one solution. So if x equals 3, That's my x value. I need a y value to go with this. So how can I get a y value? Going back up to the top and plugging in. I can plug into either equation. Which one looks easier? Definitely the linear. So plugging into the 2x minus 5, I get 6 minus 5, I get 1. So again, this is not an x-intercept. This is the point of intersection of two graphs. Imagine a parabola that has a line that touches at 3, 1. That's the point of intersection 3, 1. This system of nonlinear equations touches once at that point of intersection. Okay, let's go do this next one and see what this looks like. Also substituting in for y, or setting these two equations equal to each other, moving over the x's, moving over the constant so that it's equal to 0. Now we can factor. 3 times 7, both negative. So if x minus 3 and x minus 7 are my factors, my solution is a positive 3 and a positive 7. But x equals 3, I need to plug in and get a y value. So 3, 0 is my first point of intersection, and then x equals 7, I need to plug in and get a y value for that one. So 14 minus 6 is 8. So 7, 8 is my other point of intersection. So there are 2 points of intersection for this graph. Picture a parabola with a line going through it that touches at 3, 0 and 7, 8. And those are your 2 points of intersection of that nonlinear system. Okay, this last one, lots of people miss this on the quiz, and this is really not that bad. We just need to continue the table for the pattern. So this table represents a quadratic with a vertex at 2, -1. What is the average rate of change on the interval from 7 to 8? It gives us interval 2 to 3, 3 to 4, 4 to 5, and 5 to 6. So we just need to keep it going, 6 to 7, 7 to 8, and this is the one they're looking for. So keep it going. 1, jump of 1, jump of 3, jump of 5, jump of 7, jump of 9, jump of 11. The average rate of change on the interval from x equals 7 to x equals 8 is just 11. So it's like we don't even look at that other table. We just need the second table, and we need to continue that pattern. What do you think?